Hey, Shehraz.
Oh, hey Sam, what you got there?
Oh, this? This is just the periodic table of elements.
Oh, nice. Looks like you got the new version, eh?
Yeah, I know! The periodic table is...
Yo, calm down. There might be some people who don't know what a periodic table is.
Oh, sorry.
So yeah, instead of leaving them in the dark, let's explain it. So before we get into the meat of the topic, let's start cooking the broth with the history of the periodic table. The periodic table is one of the most important inventions in our science's history. Ask any chemistry student you know. I bet you they wouldn't have passed your class without it. The periodic table is used internationally as a way to organize elements. And even more surprisingly, it can even help us predict new elements. But that's a topic for another video. It's one of the most influential pieces of chemistry. It's everywhere. At the end of your textbooks, on posters, and even in your classrooms. It's everywhere. You would be a fool to think that behind all the metals and the non-metals on the surface of the periodic table, there would be no history behind it. If you ask anyone who's done chemistry and, well, didn't fail, who the founding father of the periodic table was, they would most certainly say Dmitri Mendeleev. Although Mendeleev did discover the periodic table, or the periodic system as he called it, back in the February of 1869, a few others before him like John Newman and Julius Mayer also contributed to the development of the periodic table. Discoveries such as arranging the table by increasing valency, otherwise known as how many other atoms it can combine with, and noticing that there were similarities between elements with atomic weights that differentiated by 7, which at the time was known as the Rule of Octaves, were discovered by the two scientists. To circle back to the main point of Dmitri Mendeleev, he originally placed the cards with the elements on them until he realized that when organized by increasing atomic weight, that certain types of elements often reoccurred, which we now know as the families of the periodic table. Furthermore, Mendeleev's table also had another huge triumph, which was that we could now predict new elements, which was done through leaving gaps on the table. Without a doubt, the periodic table is nothing like Mendeleev had first come across while shuffling his elemental deck for blackjack with all the rows and columns. So, if Mendeleev's blackjack isn't what millions of chemistry students are studying from, then someone else must have made changes to it, right? Right. It wasn't until 1913, 6 years after Mendeleev's death, that Henry Moseley introduced the final piece of the puzzle. He used the wavelengths of X-rays shot at samples of elements to calculate the frequency, and found that when the square root of this frequency was plotted against the atomic number, the graph showed a perfect straight line, which in turn gave an actual way to measure atomic number. Not only have we developed structural changes to the very foundations of the periodic table after Mendeleev's original discovery, we have also discovered brand new elements, which the system was highly praised for when it originally was discovered. So now you know how the periodic table came to be. But like with every other piece of literature or table, you have to know how to read it in order to be actually more beneficial to you than just another piece of paper. So how exactly do you read the periodic table?
As you've probably seen, the periodic table is filled with tiny little squares that contain letters and numbers. Now, when first looking at the periodic table, you probably wondered, what the heck? Or why am I even learning this? Or what am I going to have for lunch today? Sorry, I think the last one was just me. I'm a bit hungry today. Anyways, let's get on to how to read the periodic table. The letters in the square are the symbol of the element. Right underneath the symbol, you'll see the element's name. And right underneath the element's name, you'll see a decimal number. The decimal number is the atomic mass of that element. There are some elements that are light, like hydrogen, and then there are some elements that are heavy, like iodine. The atomic mass of an element is the number of protons plus the number of neutrons. Remember, electrons are not counted because electrons are mostly empty space. Now let's move on to the number located on the top left of the square. Now this is your atomic number. The atomic number and the atomic mass are different because the atomic number only focuses on the number of protons in the element, while the atomic mass is the number of protons and neutrons combined. Great, so now you guys know about the little squares, but why are the little squares in the place that they are in the table? Why is it arranged that way? Here, let me tell you. The elements of a periodic table are arranged in order of their mass. So as you go from left to right, the mass will increase. As you've probably seen, certain elements in the periodic table are grouped together in a certain color. That certain color represents a family in the periodic table. The reason that the elements are grouped together in a family is because they have the same or similar properties. I mentioned that the elements are grouped together in families. Now let's talk about the different families and their characteristics in the periodic table.
There's nothing like family, am I right? Everywhere you go, you can at least spot one family, whether that's on the periodic table or in real life. A family is just a group of people who love and care for each other because they're related in one way or another. Well, I know that elements are non-living, but still. The periodic table of elements includes a total of 9 families, but I will only be covering the 6 main ones because the rest are just further subdivisions of the larger families. Okay, so now the broth is cooked and ready to go. Only the meat of the dish remains. So let's turn the gas down and let this baby simmer. Metals are solid, lustrous, malleable, and solid objects. Basically mean that they are hard, shiny, and can be made into different objects. Along with that, they are great conductors of electricity and heat, and they also have high melting points. The families in the periodic table that fall under the topic of metals are the alkaline earth metals, the alkali metals, and transition metals, but we also like to include metalloids, but more on that later. As you can see, all these families are on the left side of the line, which we like to call the staircase. Alkali earth metals can be found naturally on the earth and are so reactive that they're usually found on earth combined with other elements. Some of the elements that are in the alkali earth metals are lithium, sodium, and potassium. Alkaline earth metals are also commonly found in nature. They have the ability to lose electrons, which can make them positively charged. We will go more into that in a future video. Alkaline earth metals include beryllium, strontium, and calcium. Now metalloids are a bit different from your common metals, as they have both the characteristics of metals and nonmetals. The metalloids include boron, silicon, germanium, arsenic, antimony. Okay, now it's time to move on to nonmetals. But before we do, here's a bad joke. What's another word for copernicium? Heavy metal. You know, like, because copernicium has a mass of... Never mind. Now that we're done with the left-hand side of the staircase, we can move on to the right-hand side, otherwise identified as the nonmetals. The nonmetals are a smaller group of elements, tiny but mighty. We can find 2 main families in the nonmetals, the halogens and the noble gases. The rest that can be identified as the elements on the left-hand side of the staircase, which aren't metalloids, or aren't any of the identified families, are identified as regular nonmetals. The physical characteristics of nonmetals in general is that they aren't lustrous, they are poor conductors of heat and electricity, when they are in solid form, and aren't ductile and are brittle, and they exist in all states of matter at room temperature. Halogens follow near identical characteristics to regular nonmetals, but one huge difference is that they're highly reactive because they only need one more valence electron. More on that whole topic in the next video. To become stable, like the next group, the noble gases, which in turn makes them much more reactive. Some elements in this group include fluorine and iodine. And last but not least, the most unreactive of them all, like me, the noble gases. All of these suckers are gases and don't want to tangle with anyone. They're completely unreactive because they have a full outer shell, meaning they have 8 electrons in their outermost shell. They're just a bunch of unreactive, odorless, colorless gases, and to be exact, the noble gases include helium, neon, argon, krypton, xenon, and radon. So, to summarize, Dmitry Mendeleev was a scientist who discovered the periodic table of elements, but he wasn't the only one who worked on the periodic table, because we have scientists like John Newlands, Julius Lothar-Meyer, and Henry Moseley, who all made major contributions to the periodic table, apart from the original discoverer, Dmitry Mendeleev. Dmitry Mendeleev had made the first periodic table in the year 1871.
If you ever stumble upon a periodic table of elements, it is important to know how to read it. Otherwise, you practically understand nothing. In a periodic table of elements, there are little squares that contain information. On the top left corner of that little square, you'll see the atomic number of that element. Underneath the atomic number, there's going to be either 1 or 2 letters. Those 1 or 2 letters are what you call the symbol of that element. Underneath the symbol, you'll see the element's name. And underneath the element's name, you'll see a decimal number which indicates the atomic mass of that element. Remember, when going from left to right in the periodic table, you'll see that the mass of the element increases.
The periodic table can be split into 3 main categories: the metals, the nonmetals, and the metalloids.
We can split the table by using the staircase, which is the physical positioning of the metalloids on the periodic table of elements.
Elements on the left of the staircase are metals, and the ones on the right are nonmetals. Metals are usually in solid form, and are abundant around the Earth. Metals are usually solid, lustrous, and malleable. Most metals are reactive, and that's why they can be found naturally combined with other elements.
And nonmetals are not usually solid. Instead, they're found in their gaseous form or found as powders. When they are found as solids, they are brittle. Along with this, nonmetals are not good conductors of electricity or heat. And so that's it. The periodic table is the best way to know everything you need to know about all the discovered elements on Earth.
So if you ever have to read one, hopefully the information you learned today helps you understand it more. Thank you guys for watching, and have a wonderful day.
Wait, Shehraz, aren't you forgetting something?
Oh yeah, don't forget to subscribe and like the video.
Remember also to turn on the notifications so that you guys can know when our next video is coming out, which is hint on covalent and ionic bonds.
Yup, and that's it. Till next time, I'm Shehraz,
And this is Sam.
and this was another Crash Course video.